Welcome to the definitive visual journey through the Lenticular DAI Gravetic hybrid saucer. This series presents a chapter-by-chapter exploration of the saucer's evolution, from its earliest propulsion physics to the most advanced interdimensional field modulation. Each schematic is rendered in vibrant blueprint style, with hypercolor overlays and detailed subsystem cutaways. Whether you're an engineer, enthusiast, or historian, this storyboard offers a comprehensive look at the technologies and innovations that define each generation. Let's begin our journey with the foundational concepts that set the stage for all that follows. Story starts with the core physics of propulsion. Here, emissions exciters, vortex stabilizers, and thrust vector control form the backbone of the saucer's movement. The schematic reveals a lenticular disc with a domed hull, surrounded by laminar airflow stabilizers and EDF thrust vectors. Plasma actuators line the rim, while a Faraday cage shields the interior. Directional arrows and force lines illustrate how aerodynamic lift and downward thrust combine for stable flight. This foundational design set the standard for all subsequent generations, emphasizing both efficiency and control. Generation II introduces gravetic integration, a leap forward in propulsion and field control. The schematic cutaway displays a central noble gas cavity encased by superconducting niobium and YBCO walls. Microwave phased array emitters excite the cavity, while green arrows indicate inertial-mass reduction pulses. Toroidal loops around the hull represent gravetic isotope gradients, shaping the field for drag reduction and hover. This generation marks the transition from purely aerodynamic to advanced field-based propulsion, laying the groundwork for inertial-mass modulation and enhanced maneuverability. Generation III, the saucer's propulsion enters a new era, the high-frequency gravitational wave, HFGW Drive. The schematic highlights a CNT-wrapped titanium rotor at the dome apex, spinning at up to 500,000 RPM. Embedded charge lattices and toroidal field-shaping shells focus the energy. White spiral arrows show rotor spin, while green arrows indicate gravitational wave pulses. Concentric rings map the propagation of these waves, enabling advanced lift and maneuvering capabilities. This chapter is a testament to the fusion of mechanical and field-based propulsion. Stealth and emissions management define Generation IV. The schematic overlays adaptive coatings and thermal vectoring on the hull. Purple arrows illustrate thermal radiation vectoring, blue arrows show acoustic damping fields, and yellow arrows indicate spectral suppression. Subsystems like phase-staggered EDFs and Faraday shielding ensure the saucer remains undetectable across RF, IR, visual, and audio bands. This generation prioritizes operational secrecy and crew safety, integrating advanced emission control into the core design. Generation V introduces ceremonial deployment protocols. The schematic features an ingress portal projecting a ceremonial energy beam downward, with blue concentric rings and white arrows for field stabilization. Subsystems like the ground eddy damping veil and spectral emitter profile are labeled. This chapter marks the saucer's transition from tactical to symbolic presence, integrating command protocols and safe crew ingress. The visual emphasizes both the technical and ceremonial aspects of deployment. Sixth generation showcases multimodal force integration, adapting the saucer for land, ocean, sky, and space. The internal cutaway schematic reveals subsystems like the CNT shell, superconducting walls, noble gas cavity, and rotor assembly. Green arrows indicate gravity reduction, white toroidal loops show field shaping, and blue arrows represent shielding modulation. This design allows seamless adaptation to any environment, ensuring operational flexibility and resilience. Generation VI focuses on the materials dossier, detailing the layered hull architecture. The schematic displays the aerodynamic shell, boron-carbide radiation shielding, triple-ply CNT laminate, superconducting liners, and gravetic isotope doping. Plasma exciters and microwave phase array emitters are also shown. Each layer is annotated with arrows indicating conduction, shielding, and field propagation. This chapter highlights the advanced materials science that underpins the saucer's durability and performance. Operational test logs define Generation VI. The schematic overlays show the saucer's adaptation across land, ocean, sky, and space. Subsystems for inertial-mass reduction, HFGW propulsion, shielding modulation, and stealth emissions are mapped with directional arrows. Each environment is annotated with specific overlays, demonstrating the saucer's versatility and robust design for multi-environment deployment. Generation IX reveals the internal dome layout and control interfaces. The schematic cutaway features anti-G form saddle seats, dual haptic grips, vertical thrust pedals, a 360-degree sensor imaging array, and a HUD projector. Neuralinked overhead interfaces and window portals with phased shielding are also shown. Arrows map control signal pathways and shielding zones, providing a clear view of the crew's operational environment and command flow. Field envelope dynamics take center stage in Generation X. The schematic illustrates layered containment and modulation fields. gravetic shells, electromagnetic containment, inertial dampening, and stealth modulation. Torsion fields, field propagation lines, and plasma vectors are mapped in vibrant overlays. This chapter integrates all prior propulsion, shielding, and stealth systems into a unified external field architecture. Deployment protocols and mission profiles define Generation XI. The schematic presents 4 mission scenarios: ceremonial descent, recon apparition, nocturnal flight, and depth ingress. Each scenario is annotated with subsystem overlays and vector arrows showing ingress beams, emission suppression, and field stabilization. This chapter demonstrates the source's operational flexibility and mission-specific adaptations. G-systems and power distribution are the focus of Generation XI. The schematic reveals the plasma anode column, fusion chamber, plasma dynamo, M8D power tap, and microwave phased array emitters. Energy flow vectors are mapped with white arrows, red coils, teal rings, and orange lines, showing convergent ion streams and power routing. This chapter integrates zero-point excitation, plasma regulation, and phase distribution for maximum efficiency. Defensive systems and countermeasures define Generation XII. The schematic displays a multi-layered perimeter defense, phased shielding canopy, plasma arrestor, mesoterminal deflection, photonic absorption mesh, magnetic pulse inhibitor, RF emission scrambler, and more. Threat interception vectors are mapped with orange rings, yellow beams, red lines, and blue waveforms. This chapter ensures the source's survivability against a wide range of threats. Navigation and sensor systems take on a futuristic theme in Generation XIV. The schematic features a quantum inertial compass, 360-degree sensor imaging dome, gravetic telemetry lattice, phased radar veil, neutrino beacon triangulator, and AI-assisted flight path predictor. Neon overlays and cosmic depth highlight the advanced data flow, radar sweeps, and telemetry couplings. This chapter enables precise navigation and situational awareness in any environment. Crew life support and environmental control are the focus of Generation XV. The schematic reveals the vapor reclaim module, water filtration tank, BioArc life cell, CO2 scrubber, thermal regulation coils, M-shielding canopy, gravetic pressure equalizer, and atmospheric composition balancer. Environmental flow vectors are mapped in blue, green, red, orange, and white, ensuring optimal crew health and safety for long-duration missions. Mission command and AI integration reach their peak in Generation XVI. The schematic, rendered in neon holographic style, features the AI computing core, mission control hub, neural synchron interface, pilot command element, crew HUD, and Starlink comm array. Visual overlays in white, pink, blue, red, orange, and purple map data flow, tactical matrices, and neural sync. This chapter enables autonomous deployment, predictive overlays, and seamless crew-AI collaboration. Final chapter, Generation XVI, explores interdimensional field modulation. The schematic, in full neon holographic style, displays the quantum torsion veil, phased reality anchor, dimensional slipstream stabilizer, harmonic field lattice, temporal phase modulator, and interbrain pulse emitter. Neon overlays and field vectors in violet, cyan, magenta, electric blue, and orange illustrate the source's ability to navigate and stabilize cross-dimensional boundaries. This chapter represents the pinnacle of advanced field experimentation and phased reality deployment. Ceremonial Storyboard unites all 17 generations into a single archival masterwork. Each chapter is framed with bold typography, hypercolor overlays, and subsystem clarity. The storyboard serves as a legacy registry, ideal for presentation, documentation, or ceremonial deployment. From propulsion physics to interdimensional modulation, the Lenticular DAI Gravetic hybrid source stands as a testament to technological innovation and visionary engineering.